Today we are going to talk about how 2D and 3D is a bit more than 5D. So that means that when we look at drone data, or using drones or UAVs to collect data, we get 2D information, which is or imagery, so just like you get from satellites. But you also get 3D information, so kind of like with LiDAR, you can get a point cloud, but now you get a point cloud from photogrammetry. But actually, by combining these two, we can get a lot more information than from having the two data sets individually.
Okay, so but isn't 3D or the point cloud kind of already the representation from the planar image from the?
It is, well, so it's a different kinds of data because also the 3D information has information about the shape. Right? That you cannot always find in the 2D data. Or even if you look at a drone, you can also get the digital surface model. But then for each pixel, so I can even show you one here. So a digital surface model is like this.
Okay.
So here what we can see is pretty much that every pixel, every part of the image has one value. In this case, the value is ranging from about 1,473 to 1,500 something.
And what are those numbers?
This is the elevation. So in this case,
meters?
Exactly, it's in meters above sea level. And so this digital surface model, or a DSM, will give you the height of each pixel. So what we can see here are the rectangular shapes are buildings, and we can also see that the bottom part is lower than the top part of the image. Okay. So if I'm a drone, you can get this, and you can also get the image, which in this case is just the visual image. And you can also get a 3D point cloud.
Okay, so from the first image, I could easily assume that this thing is built, also those houses are built on a hill. But from this image from the top, it's much more difficult to assess the height.
Exactly.
Yeah.
And you can imagine that assessing the height is important if you look at things like drainage. So if we zoom in on the image, we can see here that there are a lot of these sandbags because there's a lot of drainage issues in this area. So having then the digital surface model really helps understand, for example, where the water is going.
Okay, this will be possible already with the point cloud or just the elevation map. How does it help when you have both of them together?
So what helps is that they actually contain different kinds of information. So a typical example is if we want to automatically identify buildings. If you look at only the image, in slums it can be a bit difficult because if you take this house, for example, we can see that there are many different objects on top of the roof, right? Because there are some different corrugated iron sheets of different colors, and in this case there are some rocks on top. So it can be difficult only from the image to see that it's a house.
Okay.
But if we look at the 2D and the 3D information, we can see that it's planar, and we can use this information to help us identify the houses.
Oh, nice. Do you have an example of application where you use this?
For combining 2D and 3D information, we use it a lot for automatic mapping, for example.
So you mean computer doing the job of identifying houses or something like this?
Yeah, exactly.
Okay. And how does that work on the computer side, on technical?
So what we do is we use an artificial intelligence or deep learning techniques or machine learning. And then what we need to do is we look at the data that we have. So we have the 2D data, the 3D data, and then essentially we give the computer examples of what we are looking for. So in the image here on top of it, we'll kind of draw some examples of like, okay, this is a house, this is a tree, this is a structure. You give examples of what you are looking for. And then you can train an algorithm which essentially tries to make the computer understand which patterns represent the different objects. Then once it learns a model, you can apply it to the entire area, and you will be able to recognize the objects you were looking for, but then over the entire area.
You also have a point cloud to show us?
Yeah, exactly. So here you can see a point cloud of the same area, and we can actually see this is the front. And let's see, this is a side, and here we can see if we look at it from the side, we can also see it's on a slope. You know, we saw that earlier, that we saw that one part of the image was lower than the other. And what's really cool with the 3D image is, for example, or the 3D point cloud, is that here, for example, you can also see the sides of buildings.
Yeah.
And you can get a lot more information about the structure. So if we look at only from the top, in some cases like here, you can see that there's an overhanging roof.
Oh, right.
So sometimes the roof is actually a little bit bigger than the building itself. So if we see the entire point cloud rather than only the digital surface model, we can also see where the walls are of the buildings. And that can help in some cases if we want to know, for example, the size of buildings.
Okay, and what do you need to build this? I'm assuming this was captured, a lot of images captured through a drone or through a UAV. Is it possible to do that with a satellite?
So with the satellite, sometimes you can do a similar technique, but you have a lot less images. Okay. So you can also get 3D data, and indeed there are digital surface models, like the one that I showed you before, that are taken from satellite imagery.
Okay.
But then usually what they do is the satellite image will pass, and you only have 2 images, and you're using the 2 images to get the digital surface model. Whereas, for example, for the UAV data, we're actually using hundreds of images often. And then you get a lot of different angles, and so that's why we have much richer 3D information.
Okay, and how many images do you have, for instance, to build a model like you were showing us?
This one was a couple hundred to get it. I forgot the exact number, but it's in the range of a couple hundred of UAV images.
Okay, and how much time does it take to capture all of this?
Well, to capture this was about 1 flight with the drone. Could cover an area like this one. And then it took about 15 minutes of flying time.
Okay, thank you very much, Professor.
Yeah, thank you.
Do you want to be a GeoHero as well? Then take the first step and click the subscribe button and then the bell button to always be the first to know when one of our GeoHeroes posts a new video.